Hello and welcome to Voimatic. In this video we will present a detailed guide how to create a PLC by using PLCCreator. PLCCreator is free tool that creates a PLC from an IList. It is really powerful in a new PLC projects when you need to build your control system from a scratch. The complete process has 3 phases: preparation, generation with PLCCreator, import. Our target is to complete this final phase. This guide is based on the real-world use case to create an automation system whose signals are distributed in 3 separate cabinets with the given instrument IList from the customer. The complete guide can be found online at voimatic.com. Go to the Help menu and click How to create a PLC with PLCCreator. Let's go with creation. First, we need to determine the PLC architecture. Let's give brief introduction of the PLC architectures. PLCCreator offers capability to create a PLC using 3 different PLC architectural models. In the single rack architectural model, the hardware configuration of the PLC is limited to a single rack. This rack has the CPU module and all required I/O modules, with all signals being connected within this rack. In the single field bus architectural model, the PLC hardware configuration has 2 or more racks connected through a single field bus network. Within this architecture, one of the racks serves as the main rack, housing the CPU module. The remaining racks are distributed or remote I/O racks. In the multiple field buses architectural model, the PLC hardware configuration has 2 or more field buses along with their remote I/O racks. Also in this model, one of the racks serves as the main rack, housing the CPU module, and the remaining racks are distributed or remote I/O racks. Now let's go back to determine PLC architecture of our project. Analyzing the use case, we can see that single field bus architecture stands out as the most optimal choice for this project. The multiple field buses architecture is theoretically possible, however, we will stay with single field bus architecture for better simplicity and efficiency. This information is needed for the step 2, create IList. Let's give brief introduction of the ILists. ILists are created and uploaded by the user, and they have an essential role in the PLC creation. Based on the information they provide, PLCCreator creates the hardware configuration, together with signal to I/O module assignment, and corresponding tags with their addresses and tag aliases. In PLCCreator there is a special format of the IList for each architecture. The column structure is nested, starting from single rack architecture as a base IList. Within each architecture there are 2 IList types, device IList and signal IList. Besides the other columns, the device IList has asset library and library block columns. These columns are references to the corresponding asset library and library blocks registered on my asset libraries page. From this information, PLCCreator finds the block signals table that is associated with the library block and creates the I/O modules. The device IList can be derived from the instrument index or a similar document that has a list of the controlled devices. This transformation is done by using Excel commands and functions. Besides the other columns, the signal IList has signal type column, and based on the signal type, PLCCreator creates the I/O modules. The signal IList can be derived from the instrument IList or a similar document that has a list of the signal that shall be wired to the I/O modules. This transformation is also done by using Excel commands and functions. More detailed information for the ILists can be found online at voimatic.com under ILists menu. Let's create now the IList for our PLC. Considering selected PLC architecture and the fact that user provided the I/O data as a signal list, we need to use signal IList for single field bus architecture along with its corresponding Excel template. First, we will adapt the structure of the user IList to fit into the structure of the IList template, and then copy the user IList content to the IList template. Next, we will adapt the content of the IList template to meet the column requirements for the selected architecture. With this operation, the PLCCreator IList is created. The IList template for single field bus architecture has 5 columns. The first 3 columns, name, description, and signal type, are I/O module creation columns. These are inherited from signal IList for single rack architecture. The last 2 columns, hardware platform and group, are rack creation columns. On the other hand, user IList has 4 columns, name, description, signal type, and signal location. The names of the first 3 columns are the same with those in the template, and their contents adhere to the specified column requirements. So, they can be directly copied into the template. The column signal location cannot be found in the template, however, it provides information about the location where the signal is wired. Considering that location is a relevant grouping criterion, this column can be used as a group and its content can be copied into the template also. Please note that each distinct group found in the group column must be present on the My Groups page. This means that locations Main Cabinet, Remote Cabinet and Machine 1 shall be added on My Groups page. Please note that spaces are not permitted in group names. Let's create these groups. Log into PLCCreator. On the navigation panel, click My Groups. Click on the new group. Type the group name, in this case Main Cabinet. Optionally, you can add description. Click Save. Use New Group button to add the rest of the groups. When finished, click on My Groups. We can see our groups are present on My Groups table. Click on My PLCs to go to My PLCs page. Let's adapt the structure of the user IList. Open both the user IList and the IList template. In the user IList, select and copy the data from the columns, name, description, and signal type, excluding the heading row. In the template, right-click the cell A3 and paste the values only. Go back to the user IList and select and copy the data of the column signal location without the heading row. In the template, right-click the first cell of the group column and paste the values only. Now, let's adapt the content of IList template to match the column requirements for Signal IList for single field bus architecture. Select the data of the group column either by selecting the cells or by clicking the E column of the columns bar. Press Ctrl+H on the keyboard to open Excel Find Replace dialog. Remove the spaces in the group column. We can see we are missing the hardware platform information. This information can be obtained from the user requirements. The main cabinet shall use S7-1500, remote cabinet ET200SP, and machine 1 ET200 Pro. Click the first cell of hardware platform column and click the drop-down arrow on the right to expand cell drop-down selection. Select ET200MP from the options provided. We need to copy ET200MP to all hardware platform cells in the rows corresponding to the main cabinet group. Don't forget to paste the values only. We will repeat the same process for the other groups. Save the template with another name, and then save the template as .csv file in order to be uploaded in PLCCreator. By completing these steps, the preparation phase concludes, and we can proceed to the PLC generation phase. The next step is step 3, select CPU module. The selection of the PLC CPU module is performed on the CPU data page. To access this page, log into PLCCreator using your credentials and click the New PLC button on the My PLCs page. Considering the user requirements, set the CPU data properties as follows. For PLC name, example 1 PLC. For PLC description, we can use example how to generate the PLC with PLCCreator. For CPU manufacturer, select Siemens. For CPU software platform, select TIA Portal. For CPU hardware platform, select ET200MP. For CPU module, select CPU 15152PN. Click Save. Observe the navigation panel. We can see that PLC Architecture button is enabled. This means that we can proceed to step 4, select PLC Architecture. Click on PLC Architecture button on navigation panel. Select already determined architecture in step 1, in this instance single field bus, with Profinet as a field bus protocol. It is possible to select different architecture, however, you will need to repeat the step 2, create IList. You can download the IList template by clicking the ILists button. Click Save to save the PLC architecture. Observe the navigation panel. We can see that Upload I/O Devices and Upload I/O Signals buttons are enabled. From this point onward, it is possible to upload an IList, either Signal IList or Device IList, that corresponds with the selected PLC architecture. We can proceed to step 5, Upload IList. Considering we have created Signal IList in step 2, we need to navigate to Upload I/O Signals page. Click on the Upload I/O Signals button in the navigation panel. Click on the Upload File button, and then click the Choose File button. The File Open dialog will appear. Browse and select the .csv file of your Signal IList, and click Open. If there are no errors, the Save button will appear above the Signal iList table. Click Save. Observe the navigation panel. We can see that all buttons are enabled. The PLC is now ready to be generated. We can proceed to step 6, Generate. Click on the Generate button in the navigation panel to go to Generate page. Before initiating the PLC generation process, you must select the PLC main rack. This main rack houses the PLC CPU module. The selection process involves selection of the group, referred to here as CPU group, from the selection list. This selection list is derived from the unique combinations of the hardware platform and group columns, from the uploaded iList in step 5, where the hardware platform is the same with CPU hardware platform specified on CPU data page in step 3, plus standalone CPU group. In this instance, the selection list contains main cabinet and standalone CPU groups. Select the main cabinet group. In practical terms, the selection of the main rack means the CPU module will be inserted into the PLC rack, created from the I/O modules, required to wire the signals from the CPU group. In this instance, it is the main cabinet group. Optionally, you can set the signal contingency. This feature is very good to provide free I/O modules to accommodate future modifications of the PLC system. Before generating the PLC, you can check the signal statistics to ensure the correct inclusion of all signals from the Signal iList. Click Save. The Generate button will appear and click Generate. The PLC will be generated within a seconds, and you will be redirected to the PLC details page. Here you can download the files for import into your PLC engineering software platform. You can also download the order list, PLC report, signal report, PLC iList, browse the PLC structure, etc. Now, we are coming to step 7, import into PLC software platform. PLCCreator supports several software platforms. This step depends on the software platform selected in the step 3 on CPU data page. Considering we have selected TIA Portal as a software platform, we should import the generated PLC hardware configuration into TIA Portal. On PLC details page, click the HWConfig button to download the zip file of the generated hardware configuration. Unzip the file preferably in the separate directory. Open TIA Portal and create a new project with the same name as the PLC name from PLCCreator. On the main menu, click Tools and then Import CX Data. To open the File Import dialog, point to the directory where you have unzipped the zip file and select the .aml file that contains your PLC name and click Open. TIA Portal will start with the import of the hardware configuration. Upon completion, the racks of your PLC will be shown in the Devices tab of the project tree. During the import of the hardware configuration, TIA Portal creates the tag table 1, which corresponds to the iList uploaded in the PLC generation process in PLCCreator. However, the tag comments are not part of the hardware configuration, and they shall be imported from the tag table file provided by PLCCreator in the same zip package. The comment column in tag table 1 corresponds to the description column in PLCCreator iList. To open File Import dialog for tag table file, expand the main rack group, expand the PLC tags group, and double-click tag table 1. Click on the import icon to open the import dialog. On this dialog, click Browse button to open File Import dialog. Point to the directory where you have unzipped the zip file, select the .xml file that contains your PLC name, and click Open. On the import dialog, click OK to start the tags import process. Upon completion of tag comments import, they become visible in the comments column. You can scroll through tag table 1 to see the imported tags. You can double-click on Devices and Networks to see the PLC racks and field buses. You can further explore the modules within each rack by double-clicking the rack icon. For example, double-click rack_remote cabinet 1. To see the tags associated with the I/O module, click the module, for example slot 3, and then click the I/O tags. This is the last step of the PLC creation procedure. Your PLC hardware configuration has been created, and now you can continue with the development of the business logic, according to customer control requirements. We have demonstrated how to create a complex automation system, just from the user iList, within a minute. PLCCreator is a powerful tool that can streamline your automation projects, saving your valuable time and budget.